Hello, 7th graders, and welcome to Chapter 6 on expressions and equations. In 6.1, we're going to work on adding and subtracting expressions, as well as factoring and distributing. So as a little bit of a review, let's remember what is an expression. An expression is a math sentence without an equal sign. An equation has an equal sign. So up here, this 2 minus b is an expression, but then down here, when I add an equal sign, this becomes an equation. All right, so let's practice writing expressions with the given words. Number 1, I have the sum of 5 and a number x. Sum means addition, so we're going to add 5 and x. Number 2, 11 decreased by n. Well, we learned a couple units ago that decreased means subtract or negative, so minus n. The quotient of negative 9 and y. The quotient is an answer to a division problem. This could be read a couple of ways. I'm going to read it as negative 9 divided by y. If you read it as y divided by 9, that's fine. Twice a number minus 13. Twice a number is 2n minus 13. All right, so those are all expressions because there are no equal signs. All right, so now let's work on evaluating expressions. When we evaluate, we solve. So in this problem, it says evaluate 3x minus 5 for x equals 2. That means we're going to solve the expression 3x minus 5 if x equals 2, negative 2. We're going to substitute negative 2 for x. So see here, they plugged in negative 2 for x, and now I have 3 times negative 2 minus 5. So 3 times negative 2 is negative 6. Negative 6 minus 5 goes further from 0, goes more negative. It's negative 11. All right, so number 5. I have 2x plus 3 for x equals 3. That means I'm substituting 3 in for x and evaluating the equation or solving the equation. So 2 times 3 is 6, plus 3 is 9. All right, number 6, I have negative 4x plus 7 for x equals negative 1. So I'm going to plug in negative 1. Negative 4 times negative 1 is positive 4, plus 7 is 11. All right, I'm going to do number 9, and then I want you guys to try number 10 on your own. Okay, so number 9, 2/3 of x minus 12 for x equals 18. So 2/3 of 18 minus 12. Well, I know 18 divided by 3 is 6. So 2/3 of 18 is going to be 2 times 6, or 12. Minus 12 is 0. All right, pause the video, see if you can do number 10 on your own. Play it back to see if you got it right. All right, I'm going to go ahead and solve it. So we plug in negative 8, negative 5/8 of negative 8. Well, a negative times a negative is a positive, so that's going to be 5. And then plus 10, 5 plus 10 is 15. All right, operations with fractions. Just a reminder, when we divide, we have some steps to follow. When we divide, we switch the sign to multiplication, and we flip the second number to the reciprocal and multiply straight across. So 2/5 divided by 7/10, I'm going to change that to 2/5 times 10/7, flip the second one to the reciprocal. And then they start by simplifying, but you can just multiply straight across. 2 times 10 is 20. 5 times 7 is 35, and then simplify. So I know 20 and 35 are both divisible by 5. 20 divided by 5 is 4. 35 divided by 5 is 7. So my answer is 4/7. All right, pause the video, pick 2 of the bottom 4 to try, and then play it back and see if you got it right. Go. All right, to prepare us for some vocabulary terms, we're going to complete the blanks together. These are steps to solving an algebraic expression. First step, identify the operation performed on the variable in the equation. Apply the inverse operation to both sides of the equation. By the way, when we're doing inverse operations, we've learned PEMDAS before. That's the order of operations. When we're solving for a variable, we actually do PEMDAS backwards. So we have to undo any subtraction or division first, then undo multiplication and division. Subtraction and addition first, then multiplication and division. Okay, the variable in the equation is alone, so that's the goal, and set equal to the solution. So the goal when we're solving an equation is to get the variable by itself. Once the variable is by itself and the other side is simplified, that other side is the solution. So if I end with x equals 8.5, 8.5 is my solution. All right, so understanding the vocabulary, an algebraic expression contains at least one variable. A mathematical sentence that shows two expressions are equivalent is called an equation. All right, so lesson 6.1 is on simplifying algebraic expressions using addition and subtraction. One of the first things we're going to do is learn about like terms. Okay, so notice the box I added in the top corner. Like terms are terms with the same variable raised to the same power. These terms are separated with addition and subtraction. So before we even read the problem, I want you to look at this part. 10h and 14h are like terms. We can combine 10h plus 14h to get 24h. Now, because 28 or 25 and 18 don't have a variable, those are also like terms. So we can add 25 and 18 to get 43. We cannot combine 43 and 24h because they are not like terms. One has an h, one has no variable. We cannot combine those. So that expression would be our answer. All right, so let's read the problem. Jill and Kyle get paid per project. Jill is paid a project fee of $25 plus $10 per hour. Kyle is paid a project fee of $18 plus $14 per hour. Write an expression to represent how much a company will pay to hire both to work the same number of hours on a project. Okay, so we're going to use H for hours. First, we need to write an expression for how much the company will pay each person. Remember, an expression is a math sentence without an equal sign. I know Jill is paid 25 plus 10 per hour. $10 per hour is going to be represented with 10h, 10 times h, because it's $10 times the amount of hours she works. And then we're going to add 25 for her project fee, because 25 doesn't depend on a variable, it's just $25. Kyle gets $18 plus 14 per hour. So his $18 fee does not have a variable, and then 14 per hour is going to be 14h. Now, a company hires both of them, so we want to know the total of both of their charges. So we're going to add these expressions together. So I have 25 plus 10h plus 18 plus 14h. So we're going to add their pay rates. Then use the commutative property. If you guys don't remember, the commutative property basically just says order doesn't matter. So that means 2 plus 3 equals 3 plus 2. I can flip the order, they're both equal to 5. So I'm flipping the 10h and the 18 here so that then I can add, then I can add 25 plus 18 and 10h plus 14h. So 25 plus 18 is 43, and 10h plus 14h is 24h. Again, I can't combine 43 and 24h because they are not like terms, so that's our answer. The company will pay 43 plus 24h dollars to hire both Jill and Kyle. All right, let's reflect on this a little bit. What can you read directly from the expression 43 plus 24h that you cannot read directly from the equivalent expression 25 plus 10h plus 18 plus 14h? Well, we can read that you just plug in hours. It's going to be an initial charge of $43, and then we plug in the hours and multiply by 24. The other equation's a little longer, and it's going to be much more steps once we actually plug in h. Okay, so looking at the bottom ones, these have rational numbers in them. The other one had rational numbers, but they were whole numbers, which is a lot easier to deal with. So I want to work through number 2 in this video, and then you can try number 3 on your own. All right, so number 2 has 3x plus 1/2 plus 7x minus 4.5. So the expressions are already combined. I'm adding them together. We're going to use the commutative property to move the like terms by the other like terms. So 3x and 7x are like terms because they both have x. So I'm going to move those by each other. And then 1/2 and negative 4.5 are like terms. So plus 1/2 minus 4.5. Now I can simplify. 3x plus 7x is 10x. And 1/2 minus 4.5 is negative 4. So the answer is 10x minus 4. All right, pause the video, try number 3 on your own, play it back to see if you got it right. I'm going to go ahead and solve it. Negative 0.25x minus 3 minus 1.5x plus 1.4. We're going to use commutative property to move the like terms by each other. So I have negative 0.25x minus 1.5x. I hope this minus sign didn't trick you guys. This has to be distributed, so it's minus 1.5 and also minus 1.4. So when we do the next set, we have minus 3 minus 1.4 because both of these terms are being subtracted. All right, now we simplify. Negative 0.25 minus 1.5 is going to be negative 1.75x minus negative 3 minus 1.4 is negative 4.4. There's our answer. All right, there is a lot thrown at you in this notes video. We had both the intro to chapter 6, we had adding expressions, and now we have the distributive property. So I'm actually going to call this part of the video part 2. You're going to have 2 days of assignments on this. The first one will be on the last example, and the next part will be on this example. So, example 2. Mark is selling tickets for a high school band concert. The band gets to keep 25% of the money he collects from ticket sales to put toward new uniforms. Write an expression to represent how much the band gets to keep. All right, so we're going to let A represent the number of adult tickets he sells, and Y is going to represent the number of youth tickets he sells. So he's going to make $16.60 per adult ticket and $12.20 per youth ticket. That's what the total ticket sale is going to be. You have to read the ticket to figure that out, but that's right here, $16.60A plus $12.20Y. Now it says the band gets to keep 25% of the money that's collected from ticket sales. So that expression represents how much is collected from ticket sales, but only 25% of that the band gets to keep. So we're going to write 25% as a decimal, 0.25, and then we're going to multiply 0.25 because it's 25% of the total ticket sale. So 0.25 times the total ticket sale. Remember, A represents adult tickets, so $16.60 per adult ticket, and Y represents a youth ticket, so $12.20 per youth ticket. All right, so now we're going to use the distributive property. If you guys don't remember what the distributive property is, it's where you have a number outside of parentheses. You can distribute that number to the numbers inside the parentheses, multiply it by both, and you're going to get the same answer as if you'd done the parentheses first. So in this example, I have 2 times 3 plus 4. 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 is going to give me the same answer as if I'd done the parentheses first. So you can distribute the number outside the parentheses and multiply by both terms inside. This is helpful when we have variables because we don't know what these terms are. We can't just add them and solve. We're going to have multiple terms in our expression answer. So 0.25 times 16.6a plus 0.25 times 12.2y. So we distributed that 0.25 to both the 16a and the 12.2. Multiply it out. You can definitely use a calculator here. 0.25 times 16.6 is going to be 4.15, so that's 4.15a. And then 0.25 times 12.2 is going to be 3.05, so 3.05y. And that's it. We leave that as our answer because we don't know how many tickets were sold. We don't know what A and Y are. We just know he makes 25% of what the ticket sales are. So this represents how much the band gets to keep. We can't actually solve it. We don't know how many tickets were sold, but this represents how much they get to keep. Okay, so I want you guys to practice the distributive property. Pick one of these bottom ones to do. Solve it, play the video, see if you got it right. Go. All right, the last part of the notes video is on factoring expressions. Factoring is the opposite of the distributive property. If we were in school, we would be using algebra tiles to show how it's done, but we're just going to have to visualize it since we are distance learning. All right, so we're going to start with the expression 4x plus 8. This uses 4 x tiles. 4x is the same thing as x plus, or not, yeah, plus x. Okay, so 4 positive x tiles and 8 1 tiles. So we're going to say x, 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 x. There's our 4x, and then 8 1 tiles. Those are my 1 tiles. We're going to arrange it in a rectangle. This total area represents 4x plus 8. Now, I know rectangles are length times width. The area of a rectangle is length times width. We use area models to represent multiplication. Since the length multiplied the width equals the area, we can use that to know what factors of 4x plus 8 are. So if we count the rows this way, there are 4 rows. Each row is the same. It has x plus 2, 1 x tile plus 2 1 tiles. So the area of this rectangle can be represented as 4 1 tiles times x plus 2. So when we factor it, we're going to factor out 4 times x plus 2. Now, this is the algebra tile way to factor it. I think it's easier to just think what they have in common. So let's use another example. Let's use 3x plus 9. 3x and 9 are not like terms. One has a variable, one doesn't. But I can still think what they have in common. So I know 3 and 9 are both divisible by 3. So the goal of factoring is to take out what they have in common and get a number outside of the parentheses, just like we did here, multiplied by terms inside the parentheses. It's the opposite of the distribute. So when we distribute, we go the other way. When we factor, we take out what they have in common. So 3 and 9 have a 3 in common. I'm going to pull out a 3. And here's my parentheses. So now I do 3x divided by 3. If I take out the 3 from 3x, all I have left is an x. And then I'm going to do 9 divided by 3. So if I take out 3 from 9, 9 divided by 3 is 3. So pull out what they have in common, divide both terms by that number, and then you should have 2 terms left in the parentheses if you started with 2 terms and 1 number outside multiplying. I'm going to do a couple of these bottom ones with you guys, and then you're going to do the last 2 on your own. So 2x plus 2, 2x and 2 have a 2 in common, so I'm going to pull out a 2. 2x divided by 2 is x. 2 divided by 2 is 1. 3x plus 9, 3x and 9, oh, we just did this one together. They have a 3 in common. 3x divided by 3 is x. 9 divided by 3 is 3. All right, so pause the video, see if you can do 11 and 12 on your own. Play it back to see if you got it right. I'm going to walk through these kind of slowly, so if you feel like you could use one more example together, keep watching number 11 and then pause it and try number 12. All right, 5x plus 15. They have a 5 in common, so I'm going to pull out a 5. 5x divided by 5 is x. 15 divided by 5 is 3. Another way you could show this, so with the algebra tiles, I have 1, 2, 3, 4, 5 x's. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1 tiles. So this area is 5 rows multiplied by x plus 3. So 5 times x plus 3 was our answer. All right, last one, 4x and 16 have a 4 in common. 4x divided by 4 is x. 16 divided by 4 is 4. All right, your homework today is going to be to submit your notes. So watch the note video and submit your notes. For future days, we're going to walk through a couple examples together in the Google Meet, so wait for that to see these problems done.